Hi, welcome to the 7th functions tutorial. Today's tutorial is titled The Basic Sketch and Transformation. It is a fairly complex tutorial, so you do need to pay careful attention and feel free to press pause and rewind as often as you need to. We will be looking at a lot of examples that integrate all of the functions we have covered thus far. So, in terms of what you need to know, you need to be familiar with the previous 6 tutorials on functions. You also need to have a good understanding of your grade 10 work. There are 6 major transformations that we are going to be looking at. The first is the Y shift, then the X shift, then the expansion, the contraction, followed by the flip and the inverse. Let us take a look at the Y shift. The Y shift is when the graph is shifted either up or down on the Y-axis, keeping the X values the same. The standard form we are going to look at is f of x is equals to the expression plus the value. Let me use an example to illustrate. F of x is equals to sine of x. That is our original function. If we shift it up 3 units, our new function is going to read f of x is equals to sine x plus 3. Sine x is still our expression. The 3 is the value by which we shifted it up by. Let us take a look at what the graph will look like. The original graph looks like this. The new graph, f of x is equals to sine x plus 3, will look like this. All it is a upward shift of 3 units for every x value. I want you to now have a go at the following examples. Press pause on your DVD player, and when you return, we will go through it together. The first one I gave you to do read y is equal to 4 over x plus 3. Now when we sketch this, firstly let us look at the shape of the graph. This is my axis, x-axis, y-axis. The shape of the graph, because x is in the denominator, it's a fraction graph or a hyperbola. Now the standard hyperbola would look like that, something like that. We've now shifted it plus 3 units. Our original y asymptote was there. Our new y asymptote is going to be shifted 3 units up. So let's just erase this original graph. Our new y asymptote is the line y is equal to 3. Our x asymptote stays the same, which means that our new graph is going to look like that. Our new graph has been shifted 3 units up, and this is the graph y is equal to 4 over x plus 3. If you want to, you can put in a point. You don't need to, but you can. Let's choose an x value of 3, so that will be actually let's choose an x value of 4. That will be 4 over 4, which is 1 plus 3 is 4. That means that that point is x is equal to 4, y is equal to 4. The second one I gave you to do read f of x is equal to 2 to the power x minus 6. Start by identifying the shape of the graph. Because x is in the exponent, it means that it's an exponential graph. the standard shape of the exponential graph, that's our x-axis, that's our y-axis, standard shape of the exponential graph looks like that. Except now we've taken our graph and we've moved it 6 units downward. So it should be intercepting at x is equal to 0, y is equal to 1. It's now going to intersect or cut the y-axis at 6 units lower than 1. 1 minus 6 is equal to negative 5. That means that it's going to cut the the y-axis at negative 5. That means that our graph is going to look like that. All that's happened, and this is f of x by the way, all that's happened is we've shifted our graph 6 units downward because of the minus 6. You don't have to write in all of this, by the way. You don't have to put that in, you don't have to put that in, or that in, or that. You just got to draw that graph. Again, if you want to choose a point, you're welcome to. Let's plug in a point over there. In fact, no, in this case, why don't we just work on the axis? That's the point where y is equal to 0. That means that 2 to the power x minus 6 is equal to 0. That means that 2 to the power x is equal to positive 6. I'm going to have to use logs to work this out with a calculator. That means that log base 2 to the power 6 is equal to x, which if you work out on a calculator will give you log 6 divided by log 2, which is equal to x is equal to 2.6 rounded off to 1 decimal place. So that's the value 2.6 and the y value 0. If you want to substitute that in, you can, you don't have to. Number 3, read g of x is equal to 3x plus 4 plus 5. 3x plus 4, this is a straight line. Plus 5 means that I'm shifting it 5 units upward. Now let's look at this one. And keep this one in mind because it does come up in the next exercise as well, when we do the x transformation. Firstly, this is going to become 3x plus 4 plus 5 is 3x plus 9. When x is equal to, that's y is equal to that. When x is equal to 0, y is going to equal positive 9. And when x is equal to, and when y is equal to 0, that means that 3x is going to equal negative 9. That means that x is equal to negative 3. That means that our new graph looks like that. That is the graph g of x is equal to 3x plus 4 plus 5. Now our original graph read 3x plus 4, which means that we have shifted it 5 units upward. So our original graph in theory should have cut the y-axis at positive 4, 5 units lower. Let's see if that holds true. If y is equal to 3x plus 4, when x is equal to 0, y is equal to 4. Yes, that's true. When y is equal to 0, it means that 3x is equal to negative 4, x is equal to negative 4 over 3, or negative 1.3, which is over there. So yes, that does hold true. That means that our graph has shifted down 5 units, or rather our old graph is 5 units lower than the new graph, which means that our graph has shifted up 5 units. And it's also shifted to the left a certain amount. That certain amount is from negative 3 minus 1.3, or 4 over 3. So our graph has shifted 5 over 3 units to the left. Now I'm going to expand a bit more on this later on when we look at the x shift. The next one I gave you, number 4, read h of x is equal to log base 3x plus 4. That's my x-axis, that's my y-axis. Log base 3x, the standard log base 3x would cut the x-axis at x is equal to 1, y is equal to 0, and it would look something like that. Except we're now moving it 4 units upward. Plus 4 means that we're taking that point and we're going plus 1, 2, well, plus 1, 2, 3, 4. So our new graph is going to be this graph over here. All it is the standard graph of log base 3x, and it's been shifted 4 units upward. If you want to, you can calculate that point of intersection. In fact, I'd prefer it if you did calculate that point of intersection over there. That means that the y value is 0. That means that log base 3x is equal to negative 4. That means that x is equal to 3 to the negative 4, which means that x is equal to 1 over 81, which is a very, very small number. Very close to 0, in fact. So that's that point of intersection is x is equal to 1 over 81, y is equal to 0. All that's happened is we've moved it 4 units upward. Number 5. I said that kx is equal to 2x minus 3 squared plus 4, all of that minus 5. What have I done? Firstly, what shape is this? This is a parabola. Parabolas are a little bit trickier to sketch, but we are going to sketch it. I've taken the standard graph of this here and I've shifted it 5 units downward. So let's start by looking at this graph before we take it 5 units downward. I'm not going to do the full calculations, I'm just going to sketch it very briefly, which you should be comfortable with. My turning point is PQ. Remember, it's x minus p, so my x value is equal to positive 3 and my y value is equal to positive 4. So that's going to come somewhere over there, positive 3, positive 4. This is my original graph. Also, my y-intercept of the original graph is at x is equal to 0. 0 minus 3 is negative 3, squared is 9, times 2 is 18. 18 plus 4 is going to give me 22. That means that my graph is actually going to go much higher. It's going to cut it at 22. That means that the graph is going to look something like that. That's my original graph. Now let me look at my new graph. I'm now shifting it 5 units downward. So that means that does my x value change of my turning point? No. My x value is still going to be x is equal to 3, except my y value is now going to be 4 minus 5, which is equal to negative 1. My y-intercept, which was at 22, is now going to move 5 units down, which means that my y-intercept is going to be at positive, let's imagine that positive 17 is there. Yes, I know my graph is very inaccurate. All we've done is we've moved 5 units downward to get k of x. Notice that the first graph had no x-intercepts because 2 times x minus 3 squared plus 4 being equal to 0 means that 2 times x minus 3 squared is equal to negative 4. Get rid of the 2, which means that becomes negative negative 4 over 2, which is negative 2, we cannot square root a negative. And that makes sense because that first graph had no x-intercepts. But now let's look at our new graph. Our new graph, plus 4 minus 5, will read minus 1. That means that 2 times x minus 3 squared will equal positive 1. Get rid of the 2, so that's positive 1 over 2. We can square root positive a half. That means that x will equal 3 plus square root of a half, or 3 minus square root of a half. This point will be the point x is equal to 3 plus square root of a half. You don't need to work that out. Y value of 0. That point over there will be the point x is equal to 3 minus square root of a half, and a y value of 0. So we've gone from having no x-intercepts to us shifting it down 5 units and now having 2 very distinct x-intercepts. Also, the y-intercept has moved 5 units down, as has the turning point. The graph has not been shifted to the left or right, it's only been shifted downward. And that's the graph that you need to draw, the one in blue. We are now going to look at the x-shift. The x-shift is not that different from the y-shift. With the y-shift, we shifted the graph up or down. With the x-shift, we are going to shift it to the left or to the right. One important note, when we are adding to the x value, we are shifting the graph to the left. When we are subtracting from the x value, we are shifting the graph to the right. The standard form that we are going to be looking at is f of x, or g of x, is equals to the expression, but the x plus or minus the value by which we are shifting it by is going to be part of the expression. Let me use an example to illustrate. We are going to look at the graph g of x is equals to 4 to the power x plus 2. The plus 2 is the value that we are going to shift the g of x graph by to the left. Let us look at how that's going to play out. If I use the table method and I use the x values negative 3, negative 2, negative 1, 0, 1, 2, and 3, my corresponding y values are going to be 4 to the power negative 3 plus 2, which is 4 to the power negative 1, which is equals to a quarter, and then 1, 4, 16, 64, 256, and 1024. Now my original f of x is equals to 4 to the power x would have looked like this. My new graph, f of x plus 2, is going to look like this. We have shifted the graph 2 units to the left. If it were x minus 2, the graph would have been shifted 2 units to the right. I now want you to have a go at the following. Press pause on your DVD player, and when you return, we'll go through it together. The first one I gave you under the x shift read y is equal to 4 over x minus 3. Now, firstly, again, identify the shape. This is a hyperbola, which I don't spell right. This is a hyperbola, which means that the standard graph has 2 asymptotes. The one asymptote is y cannot equal 0, the other asymptote is x cannot equal 0. However, we've got an x transformation, which means that in this case x cannot equal positive 3. So our normal asymptote would be over there on our y-axis. Our new asymptote is, however, on our x-axis. It's moved to the right 3 units. 4 over x minus 3, standard hyperbola graph, except it's the standard graph that has been shifted 3 units to the right. And that's the graph y is equal to 4 over x minus 3. Again, if you want to, you can put a point in. You don't have to. Let's choose a point of x is equal to 4, which would be somewhere over there. When x is equal to 4, 4 minus 3 is 1. 4 over 1 is positive 4. So that would be the point x is equal to 4. Y is equal to 4 as well. Important thing, because of the x minus 3, we've shifted it to the right 3 units. Because our original graph should be over there and over there, we've now shifted it 3 units to the right. The next one we're looking at, number 2, reads f of x is equal to 2 to the power x plus 6. I'm going to now start doing the graphs a little bit faster. This is my x-axis, that's my y-axis. Standard graph supposed to be over there, cutting the y-axis at x is equal to 0, y is equal to 1. I'm now moving my graph 6 plus 6 units, which means that I'm moving it 6 units in that direction, 6 units to the left, which means that my new graph is going to look like that. It's not going to join there, by the way. That's just inaccurate of me. But it's moving 6 units that way. It is going to have a new x-intercept. Its y asymptote, it's going to have a new y-intercept. Its y asymptote of x is equal to 0 still holds true, right? But that point has shifted up because my entire graph has moved to the left 6 units. 2 to the power x plus 6 is equal to 0. That would be that point over there. That means that x plus 6 is equal to, it can't, because y cannot equal 0, which I did say is my asymptote. Right? Now let's look at the other one. When x is equal to 0 means that y is equal to 2 to the power 0 plus 6, which is 2 to the power 6, which is actually quite a high number. 2 to the power 6 is equal to 64. So that is the intercept. X is equal to 0, y is equal to 64. So it's actually been moved 63 units up and 6 units to the left. No, I don't expect you to draw it extremely accurately. All you need to do is show me that it's moved that way. But let's draw it a little bit more accurately than we have done. I'm going to use the table method for this. Like I say, I don't expect you guys to draw me very accurate graphs. The standard graph is over. If the standard graph is over there, it's actually going to increase a lot faster than that. That was my problem. We're now moving it 6 units to the right. To the left. 1, 2, 3, 4, 5, 6. That means that it's all the way up here. That makes sense, right? It was a 63 unit change. The third one I gave you read g of x is equal to 3 times by x plus 5 over 3, close bracket, plus 4. This is a straight line. Now I've shifted my graph plus 5 over 3 units to the left. Now let's look at what this will read. This will read 3x plus 3 times 5 over 3 is plus 5 plus 4, which is equal to 3x plus 9. Where have we seen that before? Remember from the previous exercise, also number 3, I had g of x is equal to 3x plus 4 plus 5. 3x plus 4, all in brackets, plus 5. And didn't that work out to the same thing as this? With straight lines, the x shift and the y shift are almost the same. It's all related to the gradient. If the gradient is 3, and for example with this one here, I shifted my y up 5 units, it means my x will be shifted negatively 5 over 3 units. So that means that this graph here will now look like this. When x is equal to 0, y is going to equal positive 9, and when y is equal to 0, x is going to equal negative 3. Whoops. Which is what? 3 and 9. That's the graph g of x, which has been shifted from the original graph over here, which was my original graph 3x plus 4. So I've shifted it 5 over 3 units to the left. We'll go through a bit more on this later on. The next one I gave you to do read h of x is equal to log base 3 x plus 3. This is going to be a standard log graph, except instead of it intersecting the x-axis at x is equal to 1, y is equal to 0, it's now moved plus 3, or rather it's moved 1, 2, 3 units negatively. That means that my asymptote, which was x is equal to 0, is now going to be 3 units in that direction, which means that my new asymptote is x is equal to 0 minus 3, which is negative 3. That means that my new log graph is going to look something like that. And that's going to be the graph of h of x. That's my y-axis. If I want to calculate my y-intercept, we're going to say x is equal to 0. That means that y is equal to log base 3 of 3, which is equal to 1. So that will be a y value of 1. So my graph is a lot more curved that way. But I'm not going for accuracy here. The last one I gave you to do read k of x is equal to 2 times x plus 2 minus 3 squared plus 4. This is a parabola because the x is squared. What I'm going to do with this one is I'm going to start by changing the form of that. That's going to become 2. X plus 2 minus 3 is the same as x minus 1 squared plus 4, still stays the same. That means that my turning point is going to be 1 and 4. X is equal to 1, y is equal to 4. So my turning point is over there. What I'm going to do with this, because my graph is going to end up looking like that, let's bring my x-axis down a lot. So that's my y-axis. Let's put my x-axis over here. The turning point of 1 and 4 is going to be somewhere over here. That means that my graph is going to look like that. My y-intercept is when x is equal to 0. That means that y will equal 2 times 0 minus 1 is minus 1 squared is 1 plus 4, which is equal to 2 plus 4, which is 6. And that is the graph of kx. Now the original graph, before we shifted it plus 2 units, means that it was 2 units this way. Still a similar turning point. The new turning point is x is equal to 1, y is equal to 4. The original turning point would have an x value of 1 plus 2. The original turning point would have been 3. The y value still 4. And that would have had a different y cut. I'm not going to go through what the original y cut would have been or what the original graph would have been, but the important thing is that we've taken our graph and we've simply shifted it 2 units to the left. Unfortunately, with straight lines and with parabolas, we cannot take the standard form of the graph and just shift it around the same way we could with a hyperbola, an exponential, or a logarithmic. With a straight line and a parabola graph, we've got to first work it out, and then we've got to sketch the graph as if we're sketching a whole new graph. I now want to just look at a relationship of the straight line between the x shift and the y shifts. I'm going to start off with a graph that reads y is equal to x plus 3. Simple graph. When x is equal to 0, y is equal to 3. When y is equal to 0, x is equal to negative 3. Which means that that graph looks like that. It has a gradient of negative 1. And I'm just going to call it y for now. Y is equal to x plus 3. Right? Now, let us look at one shift. Let us start by doing an x shift. I'm going to move it plus 2 units. So I'm going to say plus 2 next to the x. Alright, let's draw that graph in blue. Let's just expand that axis a little bit more. Okay, so now our graph is going to read x plus 2 plus 3. But isn't that the same as y is equal to x plus 5 if I take the brackets out? So when x is equal to 0, y is going to equal 5. And when y is equal to 0, x is going to equal negative 5. That means that I've shifted my graph 2 units upward. Fair enough. And I've also shifted it 2 units to the left, because the gradient was 1. So when m is equal to 1, remember it's of the form y is equal to mx plus c. When m is equal to 1, the y shift is the same as the x shift. Now let's look at when I'm working with a bigger gradient. Let's say we have y is equal to 2x plus 3. And we are going to work with y is equal to 2 times x plus 2 plus 3. This one will, when x is equal to 0, when x is equal to 0, y will equal 3. Fine. When y is equal to 0, x will equal negative 3 over 2. Which is over there. So that's the original graph. I'm now shifting it plus 2 units, which means that I'm taking it over there, 2 units that way. But it's also shifting upward. Let's look at how much it's shifting upward. Remember, the original intercept was at 3. Now when x is equal to 0, that's going to become 0 plus 2 is 2 times 2 is 4 plus 3 is 7. That point is 7. And I've shifted it 2 units that way, 2 units to the left. 2 units to the left was accompanied by a 4 unit upward shift in the y. That means that if my gradient is greater than 1, multiply my gradient by my x shift to get my y shift, or rather the y shift is equal to 2 times, or rather is equal to the gradient m times the x shift. Or the other way around, the x shift is equal to y divided by m. But this way is simpler. The y shift is equal to the gradient multiplied by the x shift. This is not necessarily part of your syllabus, it's just a side discussion, but I want you to think about it. Now let's look at this graph. Let's say we have y is equal to minus 2x plus 4, and our new graph y is equal to minus 2x plus 1 plus 4. Our x shift is 1 unit to the left. That means that our y shift is going to be negative 2 multiplied by our x shift, which is 1 unit to the left, which is negative 1, which means that our y shift is 2 units upward. Interesting one for you to think about. Like I say, not part of the syllabus. We are now going to look at expansions and contractions with regard to graphs. We get two types of expansions. There is a vertical expansion and a horizontal expansion. A vertical expansion occurs when we put a whole number in front of the y variable. A horizontal expansion occurs when we put a whole number in front of the x variable. We then move on to contractions. A contraction is very similar to an expansion, just the opposite. When we are looking at a contraction, again we get a horizontal and a vertical contraction. When we are looking at a vertical contraction, we are putting a fraction in front of the y variable. When we are looking at a horizontal contraction, we are putting a fraction in front of the x variable. I know this does sound a little bit airy-fairy at the moment, but we are about to move on to examples to illustrate. I want you to have a go at the following examples. Notice that each question has an a and a b function. It also has one table with particular x values, and then two slots, one to slot in your f of x results and one to slot in your g of x results. All of this is provided in the workbook. I want you to first fill in the table. I then want you to sketch both of the graphs on the same set of axes. Do that for all of the next questions. Press pause on your DVD player, and when you return, we will go through the examples together. The first example I gave you to do read f of x is equal to 3x plus 5 and g of x is equal to 3 times 2x plus 5. I then gave you two very small tables with the x-intercept and the y-intercept, or rather the y-intercept and the x-intercept, and I wanted you to calculate those 2 points. Most importantly, identify that this is a straight line, hence we only need 2 points to sketch it. In this first case, when x is equal to 0, y is going to equal 3 times 0, which is 0, plus 5, which is positive 5. Oops, it's over there, positive 5. And when y is equal to 0, that's going to read 0 is equal to 3x plus 5. That means that 3x is equal to negative 5, x is equal to negative 5 over 3. X is negative 5 over 3. And there's 2 points which I can use to sketch this graph. Before we do sketch it, I'm just going to draw this other graph. Gx is equal to 3 times 2x plus 5. When x is equal to 0, that's going to be 0 plus 5, which is 5. When y is equal to 0, that's going to read 0 is equal to 3 times 2x, which is 6x plus 5. 6x is equal to negative 5. X is equal to negative 5 over 6. Now I'm going to sketch both these graphs on the same set of axes. The first graph I'm going to sketch in red. We've got our axis, our y-axis, and our x-axis. Not very accurately drawn. First one, when x is equal to 0, that's on that line. Y is equal to negative 5 over 3, which is nearly negative 2. Negative 5 over 3 is almost negative 2. So that's going to go over there. Negative 5 over 3. That's when x is equal, no, sorry, when x is equal to 0, y is equal to positive 5. X is equal to 0. Let's take it a little bit higher and let's put our positive 5 over there. I'm going to draw this one in red. So that's going to be that point over there, 5. The other point when y is equal to 0, that's along that line over there. Remember, that's the y-axis, that's the x. When y is equal to 0, x is equal to negative 5 over 3, which is basically negative 2, or not basically, but close enough. So it's going to go somewhere over there, negative 5 over 3. That means that if I sketch this graph, it's going to look something like this. And that's the graph f of x. We are now going to sketch in blue the graph g of x. When x is equal to 0, y is equal to 5. So it's going to cut through that point as well. Except when y is equal to 0, x is equal to negative 5 over 6, which is half of that. So that's the point, let's just write it over here, negative 5 over 6. That means that it's still having the same y-intercept, except its x-intercept is slightly smaller, which means that our graph is going to look like that. It's going to cross over there, and that's the graph g of x. Notice all that's happened is the slant has changed. It's become more steeply sloped. If that 2 was a fraction, for example a half or a third, the original graph would be less steeply sloped. The next question I gave you to do read f of x is equal to 2 to the power x and g of x is equal to 2 to the power 2x. Let's start with f of x. When x is equal to negative 2, y or f of x is going to equal 2 to the power negative 2, which is positive 1 over 4. X is equal to negative 1, that's going to be 1 over 2. X is equal to 0, that's 1. X is equal to 1, that's 2. X is equal to 2, that's 4. With g of x, it's going to be slightly different. When x is equal to negative 2, y is going to equal 2 to the power 2 times negative 2. 2 times negative 2 is negative 4. So y is going to equal 1 over 16. When x is equal to negative 1, that's going to be 2 to the power negative 2, which is equal to 1 over 4. When x is equal to 0, that's 2 to the power 0, which is equal to 1. When x is equal to 1, that's 2 to the power 2, which is 4. When x is equal to 2, that's 2 to the power 2 times 2, which is 2 to the power 4, which is equal to positive 16. Again, I'm going to draw these two graphs in different colors. This is my x-axis, this is my y-axis. I'm going to start by drawing f of x in blue. When x is equal to negative 2, that's somewhere over here, x is negative 2, y is equal to a quarter, so that's way down here. When x is equal to negative 1, y is going to equal positive 1 over 2, so that's up here. When x is equal to 0, y is going to equal 1. When x is equal to 1, y is going to equal positive 2. And when x is equal to 2, y is going to equal positive 4. So basically we've got an exponential graph. We've got an exponential graph that's doing something like that. Obviously it's never going to touch our axis. My graphs are fairly inaccurate. And that's f of x. Now looking at g of x, I'm going to draw that in black. G of x is 2 to the power 2x. When x is equal to negative 2, notice that y is equal to 1 over 16, which is a lot lower than the original point. When x is equal to negative 1, it's 1 over 4. When x is equal to 0, it's still 1. When x is equal to 1, it's going to be 4. When x is equal to 2, it's going to be 16. Now look at this graph over here. It's going to still intersect at the y-axis at a value of 1, but it's going to, in the negative x-axis, it's going to go below f of x, and in the positive x-axis it's going to go higher than f of x. Basically all that's happened, because of that 2 in front of the x, we've sort of contracted our graph like that. Whereas if that was a fraction, we would have expanded it out a lot more. The next one I gave you to do read f of x is equal to 2 to the power x, which is the same as the previous example, and g of x is equal to 2 to the power a half x. 2 to the power x, when x is equal to negative 2, that's going to be positive 1 over 4, 1 over 2, 1, 2, 4. When x, in this case, 1 over 2 times x is the exponent. When x is equal to negative 2, that's going to be 2 to the power negative 2, which is equal to, negative 2 times half is negative 1. So that means y is going to equal 2 to the negative 1, which is 1 over 2. When x is equal to negative 1, that's going to be 2 to the power negative a half. 2 to the power negative a half is 1 over square root of 2. When x is equal to 0, that's going to be 2 to the power 0, which is 1. When x is equal to 1, that's going to be square root of 2, because it's 2 to the power a half. And when x is equal to 2, that's going to be 2 to the power 2, which is 2 times a half is 1. 2 to the power 1 is 2. Looking at our axis again, x-axis, y-axis. The first graph I'm going to draw in blue again. 2 to the power x, it's going to cut through at x is equal to 0, y is equal to 1, and all those other points are going to slot in. For example, when x is equal to negative 2, that's going to be 1 over 4. When x is equal to negative 1, that's going to be a half. And when x is equal to 0, that's going to be 1. When x is equal to 1, that's going to be 2. And when x is equal to 2, that's going to be 4. So our graph is going to be slightly more curved. And that's the graph f of x. Now in black I'm going to draw the graph g of x. 2 to the power a half x. Notice when x is equal to -2, y is going to equal a half. So it's basically double that at that point. When x is equal to -1, it's going to be 1 over root 2, which is very close to 1, just underneath it a little bit. And when x is equal to 0, it's also equal to 1. When x is equal to 1, it's equal to root 2, so it's then going to go just a little bit underneath it. And when x is equal to 2, y is equal to 2, so that's going to go somewhere over there. Notice something, it's still the shape of the exponential, except it's curving below f of x in the positive x-axis and above f of x in the negative x-axis. The next one I gave you to do was a logarithmic graph. It read f of x is equal to log base 3 to the x. When x is equal to 1, log base 3 to the 1, any log to the power 1 is always going to be 0. When x is equal to 2, that's going to be log base 3 2, which is going to give me an answer of 0.63 rounded off. When x is equal to 3, that's going to be 1. Y is going to equal 1. That's of f of x. Of g of x, we've got log base 3 to the power 2x. When x is equal to 1, that's going to be log base 3 to the power 2 times 1, which is the same as that answer of 0.63.